In this video, we'll look at the sum and product principles, which are both counting principles, and they can be considered the two most basic of all counting principles. And then these are used to build other more complex counting principles on top. So first, let's start with the sum principle. The sum principle says, in its essence, if you have a bunch of sets and they're all disjoint, meaning that there's no overlap, and you want to make one choice and pick an item, and it could be from any of the sets, then it tells you how many possible choices you have. So let's say we have disjoint sets, and I'm going to use 2 sets here, but you can extend this to 3 and 4 and 5. So let's call these sets A and B. And disjoint, remember, means no overlap. So you have set A and you have set B. And we want to make one choice. We want to choose one element, and it could either be from set A or set B. And the sum principle says, so here's the actual statement of the sum principle. It says that we have the number of elements in A plus the number of elements in B possibilities. I'll say possible choices. Kind of a typo. This is possible. So we have the number of elements in A plus the number of elements in B possible choices, possible outcomes. And that's pretty straightforward. It might seem obvious, but that's our basic principle. So let's look at a quick example. And let's say we have this scenario where we're getting ready for the day, and we have to choose what we're going to wear on our feet. So we want to wear one type of shoes, but we have 2 different types we can pick from. So we want to wear either sneakers or sandals. Obviously, we can't wear both. We have to pick either sneakers or sandals, and we have a certain number of pairs of sneakers and a certain number of pairs of sandals. So we have 3 pairs of sneakers. And we have 2 pairs of sandals. After all, we're reasonable people. So how many choices do we have? The sum principle would say we have, since these 2 sets are disjoint, we can't wear sneakers and sandals. We have to pick one of the 2. So we have 3 plus 2, that's 5, obviously, possible choices. That's the sum principle at work. So again, the sum principle, we make one choice, but it could be from this collection of disjoint sets. And all the sum principle says is the number of ways that we can make that choice is just the sum of all the sizes of the sets. So here's the product principle. The product principle also involves making choices, but now we're going to make a sequence of choices. And then again, we have a sequence of sets, and we want to choose one element from each of the sets. So say we have 2 sets again. So again, I'm going to state this for 2 sets, but it could be for any number. So let's let A and B be sets. So we want to make a sequence of choices, and here we're saying now that we have our 2 sets, we're going to choose one element from A and one element from B. So our final outcome will be this ordered pair, where we have one element from A and one element from B. Then the product principle itself states this. It's going to tell us the number of ways that we can make this sequence of two choices, in this case, is the product of the cardinalities of A and B. So in other words, the number of possible choices. And we'll say sequences of choices. Is number of elements in A times the number of elements in B. So that makes sense, because when we make our first choice, we can choose any of the things in A, and then given each of those choices, I have this many choices to make for the second element. And so each choice in A gives rise to B number of choices in B. So let's follow a similar type of example as before. Let's say again, we're still getting ready for the day, but we're not going to choose shoes. We're going to choose our outfit for the day. So we have shirt and pants. And unlike the footwear, we don't want to choose either a shirt or pants and not both. We should probably choose both. So we're going to construct an outfit, and an outfit is a sequence of two choices, one shirt and one pants. So we have 12 shirts, and we have 5 pairs of pants. So our question here is how many, we'll call them outfits. How many outfits are possible? And we're not taking into account matching or anything. So an outfit, again, it's a sequence of two choices, one from the set of shirts, one from the set of pants. And so here's our answer by the product principle, 12 times 5. That's how many possible outfits. So like I said, the sum principle and the product principle were here stated for 2 sets, but I could easily do the same thing for 3 sets, for 4, for any number of sets as long as it's a positive integer. If I had, say, 3 sets here, like shirts, pants, and socks, I would just have the product of 3 numbers instead of 2. So it's easily extendable, but it's also easily seen for 2 sets. And those are the basics of the sum and product principles.